Welcome. Now I'm going to describe our project, which is working by classifying antique books. For example, we can look these pictures that one can understand it. It's really old books, as it can be seen here. Yes, such books are named as antique books in Turkey, also in Europe. For example, this one is Greek, this one is French, this one also French, Congrès Scientifique. This one is English, it seems, in French. There are a lot of antique books, even in Latin, as you can see in here. And our project, as it can be understood from the name, is a classifier, an apparatus, of course. Let me explain how it works. In here we see a schematic that describes how the system, the antique book classifier, works. Here we have a camera as an input device. After it there is a extractor which does the extraction part. After it we have a search module to search the internet servers for the antique books as abc.com. In here the Ethernet module can be seen. From there the data goes to Ethernet, goes on Ethernet to internet servers, and also the data comes backward as a feedback. After it, the found data can be displayed on the display. We use a display in a parallel interface, PMOD CLP, and we use a camera, PCAM5C, and all these modules will be realized on a Zybo card, FPGA card. The extraction part is, of course, the most important part of the system, and we develop an algorithm on MATLAB. Here you can see it in Octave, but the extractor works with a finder and a correlator. Let's see what is this finder. In finder we use singular value decomposition to take an image and plot it. This taken image comes from the camera by letter, and in correlator we can see that a simple correlation function, a dot product, is being held. Letter by letter segmentation can be seen in here. As you can see, if the image is in RGB format or in black-white format or in gray format, it goes in this direction in this code, and in here one can see it in black-white. After it, we use a simple segmentation technique. We search the rows for a change, and if we find a change, it means that we have something in there. And after it, we search for the changes in vertical axis, and if also there is a change after the first change, it means that the anomaly ends in there. By this system, we basically have the letters in the text. For example, for our situation, the text means the title page of the book, the antique book. After all of these, in here we have, of course, another singular value decomposition system, as one can guess. To use those, as I've said before, we use correlator system. The dot product is basically the most important thing, but also the simplest thing in this situation. But as one can guess, implementing such systems in FPGA is hard, and sometimes it's too hard. So in this manner, we make simple these techniques, these algorithms, into a vectorized form, and the dot product is remaining at the end, but now we do not calculate the singular value by singular value decomposition. We are just vectorizing the letter matrices, and as a result of all of these, now this algorithm is FPGA implementable, as one can understand. Thanks for watching.